We ready?
Ready when
Yeah.
you are, Tiffany.
Okay. Good evening, everyone. Thank you for joining us on our webinar series for the spring 2025. My name is Dr. Tiffany Grant Simmons, and I am one of the graduate assistants for the Ed Tech department at NJCU. We also have Mr. Jamal Johnson, who is another graduate assistant in the department. I'm going to turn it over to Dr. Dana Mason, who will be talking about our lovely educational technology program at NJCU.
Thank you so much, Tiffany. Hello, everybody. Tonight's a really special night. So first, I want to share a little bit about our department and then a little context of what you'll be seeing this evening as we get started. So our program is nationally recognized as the Educational Technology Department at New Jersey City University. The EdTech department is ranked first nationally for affordability and student-centered learning. The MA program is ranked third nationally as an online technology program, and the doctoral program is also ranked ninth nationally for affordability and return on investment. Our degree programs include the Master of Educational Technology, which is a 36 credit fully online program. There are no tests, there are no exams. What we do is project-based learning. So everyone has a chance to learn and bring in whatever their background is and infuse it with technology. It's an exciting program. Actually, that's what you're going to be kind of participating in this evening. Is our presenter tonight is going to this is the film fulfillment for the thesis that this particular student chose. So it's very exciting, and you'll be able to see kind of a blend of how technology is used with that individual's background and professional experience. The MA Educational Technology Specialization in School Library Media is also another master's program that we have. It is also 36 credits, fully online, and the same project-based learning. This will get you certified for being a school library media specialist in the state of New Jersey. Then we also have the EdD program, which is our doctoral program in educational technology leadership. So when you're finished with your master's degrees, come on over and get your doctorate. And again, same thing. We have project-based learning. This is also online program. And what I love about this is we actually have 1 week in person. That's the only time that our students and faculty come together. It's a summer institute, and it's a great learning experience. You meet everybody, and it's a great way of really getting yourself started with everything. And you have one every summer for each of the 3 years in the program. Otherwise, everything else is online, and it's a 60 credit program. So with this particular doctoral program, you will be done in 3 years. So if you have questions about that, I'll put some information in the chat. You're more than welcome to reach out to us should you have questions. If a degree program isn't exactly the path you're looking for at this time for higher attainment, there are also different types of certificates that you can obtain. So we have this Assistive Technology Specialist Certificate, which is a 1 year program, fully online, as are all of our other courses. And this is 5 courses total, 15 credits. And this teaches you how to implement technology for students with special learning needs and different aspects of that for teaching and learning in the classroom. It's great if you have a special ed background, and it's especially great if you don't, because it helps you learn about different ways to meet your students wherever they are in terms of their need and help them find ways to be successful through technology. We also have a STEM certificate. This is a 4 course program, 12 credits. And between the assistive technology and the STEM program, these credits are also transferable into our master's program. So the STEM certificate has these 4 credits, and you learn how to use convergence education, a combination of science, technology, engineering, arts, and math, and work that in with whatever subject you're teaching. So it doesn't have to be that your domain is in those areas. In fact, it's even better if it isn't, because you learn how to work that in with either early childhood, history, music, like my background, and all different types of things. So wherever you are on the educational spectrum, STEM and STEAM and convergence education has a place within your classroom, and that's what this program focuses on. So our contact information is down here at the bottom, and I'll put it in the chat as well for anybody who's tuning in. But before we get too ahead of ourselves, I'd like to turn it back over to Tiffany, our graduate assistant, who is going to introduce our presenter for this evening.
Thank you again, everyone, for tuning in and joining us. So this evening we have our presenter, whose name is Mark Jarsky. He is the current Chief Observatory Technician and College Laboratory Technician for Engineering, Earth, and Environmental Science at the College of Staten Island. He was also at the Geoscience Library, a Geoscience Library Technician for the former Earth and Environmental Science Department at NJCU for 14 years and assisting and running the EESC labs and programs. During his tenure as president and observatory chair for the North Jersey Astronomical Group based out of Montclair State University, he developed the Electronic Assisted Astronomy program for public outreach, which is still used to this day. The technique has also spread to Amateur Astronomers Inc., which is based out of Union College and utilized during weekly public outreach events at Sperry Observatory. As an observatory technician at College of Staten Island, he holds weekly public telescope nights where there along with simultaneously conducting observational astronomy labs on site utilizing the same EAA techniques. So without further ado, we have Mark. Please take it away.
Okay, thank you for that long, lengthy introduction. Appreciate that. Let me just make sure I can share this. Okay, everyone. I'm glad to meet everyone tonight. As you said, my name is Mark Jarsky. I'm educational technology master's candidate, and also completed a STEM certificate here at NJCU. I'm again a former employee of NJCU, so this is my old home roots. It feels like coming home, so I'm glad to be here with everyone. So. My thesis or my project proposal is astronomy education is looking up an electronic assisted astronomy proposal for future K-12 and higher education courses. And it's a content analysis. So, and my advisor was Dr. Samantha Kozar, who was a great mentor to me through this entire process. I have to thank you very much for that. Okay, let's get on our way here. So we're going to look at the table of contents and then briefly go through things. We're going to cover what is electronic assisted astronomy, or EAA for short, some of the benefits, some of the technology that's on the horizon, and then we'll dive into the research questions, data collection process, data analysis process, review of data collected, results and conclusions, and how the results add to the body of research, implications for individuals in this particular field, along with suggestions for future study, and our conclusion. After the conclusion, we'll have about a 7-minute video. It's a compilation of videos of what electronic assisted astronomy looks like in action. If this were, hypothetically, if this were 6 o'clock in December, I would be able to actually show you what the telescope is doing. But now our sunsets are much later, closer to 8 p.m., so we won't be able to open things up till much later. So on we go. So what is EAA? EAA is essentially, it's enhanced real-time viewing of faint astronomical objects on a screen. So basically, we use a screen instead of an eyepiece. The traditional EAA setup, which is what you see behind you here, and if, for instance, if anyone's wondering why the screen is red, or the built room is red, the red light interferes with dark adaptation of your eyes the least. So visual observers in particular will use red light. So when we use red lights so people can see their way up and down without hurting their night vision, and it's kind of important. But for EAA, it's a little bit less important. So usually we only leave the lights dim so the telescope doesn't have extraneous light coming in. So a traditional setup like this is a large ish for an amateur instrument or a professional. It's right on the borderline of an amateur professional instrument. It's a 16-inch telescope, and we mean that by the aperture, the amount of the lens or the mirror, how much light it can gather. So that the telescope is basically acts as the lens and the light gathering instrument. There is an astronomical camera, although you could use a DSLR if you had one. Not quite as good because it doesn't have the cooling properties. A focal reducer, if necessary, depending on the telescope design. This one does because it's a slow scope, and I'll get into that. some type of software and a computer, and there's many different types, along with a screen or a monitor. And the screen or monitor can vary depending on your audience. This particular night was a small session with a small lab with about a half a dozen students. But if you're doing a large group, you can do a large screen, and you'll see what that looks like. So I want to talk for a second about what EAA is not. It is not astrophotography per se. The astrophotographers out there will, if you notice the difference between the two photos of the same object, this is the Rosette Nebula, it's a wintertime object. It's a little bit to the left of Orion. The picture on the left is a lot more detailed because it took about 30 hours of data acquisition and then processing all of these different images, stacking them together to create this highly detailed image. And that's the thing that's often considered the dark art by some people. So there's a lot of technique involved. EAA in particular, in modern times, it's much more straightforward. Yes, there's different types of software. It can get more complex, but you can, use, for instance, CWOs, ASI Live, and get the results that you see to the right on the right-hand side, and that's only after 8 minutes of exposure. It started to look as good as this before 3 minutes. So, I let it go on to 8 to capture more data. But so the whole idea is you want to capture light quickly, especially if you have a live audience or a classroom. The reason being, you want to give them something to show, and the audience gets to see the data being built up over time. So you're seeing something in real time here, as opposed to something that's a static picture. What EA also allows you to do, you can save the pictures, and this is a saved picture of that data collection. So again, we were talking about screens and screen sizes. You can use any type of screen you want. This is just at Jenny Jump State Park. This is that dark sky site. We had a slightly bigger audience, so we brought an 8-foot screen out. We've done workshops for Passaic County parks, where we've had a 40-foot inflatable screen and an entire baseball stadium full of people. So that it depends on what your purpose is. So the major benefit of EAA, in particular for this talk, is it works in light polluted skies. And so when I talk about visual astronomy, I'm talking about a telescope and an eyepiece and the human eye, you can't see faint celestial objects well at all in city skies. So if you look at the scale below, the Bortle scale, let me go back here. It goes from a dark sky site all the way to the right to a fully light polluted inner city environment. And if you look out the dome slit, the picture of the telescope, it matches up with the Bortle 8-9, the highly light polluted sky where, you can barely see any stars. So again, because of this screen, and it allows you to have a classroom style collaboration environment. And that's the other major benefit. One of the newest parts of EAA are these new smart telescopes, and this is actually newer technology, and I'll come back to this slide later on, and it may depend on individual teachers and school districts that maybe they don't have the astronomy expertise of how to use fancy equipment. This may be something that you can use with your students and bring out and put back on the shelf later on. So this is an option to consider later on. The high end part of this, so look, we saw the other ones that were on the low end. This is the high end version of that telescope. This is a very fast telescope. When we talk about optically fast, short focal length, it brings a lot of light down in a short period of time, and that's really good for an audience. So this is the high end of that scale, closer to $4,000, which is a little expensive. The other ones start as low as like $300. So there's a huge gap in between. And so when we start getting into the study, is EAA a fit for is EAA a fit for astronomy education? Can it be utilized as an observational astronomy lab component in K-12 and 100-level astronomy courses? So these 100-level astronomy courses are these beginner courses. Maybe a major has just started their journey and they haven't really moved to a higher level astronomy and physics courses where you're actually doing data processing. But this will actually introduce you to some of these processes without losing your attention. And so this also could be a way to recruit majors if you're a physics and astronomy professor. So getting to the research questions. So there's actually 4 of them. Research question 1, is there a relationship to the rise of EAA used by amateur astronomers as light pollution increases? Are not-for-profit astronomy organizations including EAA as part of their educational outreach programs? So sub-question R2A, did they consider using online or virtual-based outreach? And this is the other one that would hopefully tie things to education a little bit more. How did astronomy educators change their mode of instruction because of COVID-19? And basically, we're looking to see, were they open to changing what they were doing for many, many years because of COVID-19? So the data collective process is, again, this is a proposed, exploratory study. And so it's a qualitative content analysis, and I use the inductive reasoning method. So inductive reasoning is often good to uncover trends and possible insights. So if you look at the small diagram to the right, you're observing a bunch of data, you're trying to look for things, patterns, trends, and then hopefully you're drawing some kind of conclusion. Where is this going? I chose a purposive sampling approach, particularly to find individuals with relevant knowledge and experience. And there aren't that many resources available because this is a relatively new phenomenon, particularly catching on in the astronomy community in general. There's some limitations to talk about in this method. It's non-random sampling. So basically, I'm going out and looking specifically for people with experience to bring this to the forefront. So it's not necessarily representative of the entire astronomy community as a whole. That being said, because it's exploratory, this can be beneficial. And also there's researcher bias. I am the only researcher here at this point because it's in its exploratory mode. Plus, I am also a practitioner of electronic assisted astronomy. I'm also a practitioner of astronomy in general. I'm also a visual astronomer. So I have what you would say skin in the game, but I try to remove that out of the equation as much as possible to try to stay objective. So off we go. So I utilized a somewhat non-conventional method, mostly because, once again, there's not much in the way of professional peer-reviewed articles on this subject. It's mostly in the amateur community. And so what I wound up choosing was the Cloudy Nights message board. It's one of the most recognized astronomy information sharing sites in the United States and actually worldwide. There's plenty of members that are from Europe and Asia, and particularly in Europe, that also share on this particular message board. It in of itself is also an example of constructivist type learning. So why do I say that? You have individuals that are complete novices put in the same message board and room, essentially, with people that are longtime astronomers. They've been doing this for a very long time, professionals, and retired professionals, and people that are even in the education community as well, all mixed together to be able to share knowledge with each other. So that in and of itself, you're putting them together and they can talk to each other and suggest things, because a lot of times you'll have people that they're trying to find a solution to problem X, and you'll get 6 or 7 different answers and reasonings. And by the time you get to the end of the thread, hopefully you found a solution. And sometimes it's trial and error. They'll go out and try it physically with the telescope and come back and report and say this worked or didn't work, that sort of thing. So the conceptual framework of this study is also the technology acceptance model, the TAM. So there are ethical considerations. This is technically a members-only forum. However, if you or anyone right now can go on to Cloudy Nights and go through the message board and read through all these messages, you can put a Google search in, and the first thing that'll come up, anything astronomy related, is almost always a Cloudy Nights forum post. Actually, many of them will come up. So this is usually the first thing you'll see in a Google search. If you have an astronomy equipment-based question, in particular, the Cloudy Nights will come up. Again, the data for this was collected for research questions 1 through 2A, right? And particularly, we concentrated on the subboards EAA and the outreach board. So basically, we're going in that direction of education because astronomy clubs do practice outreach. And basically, that's their own astronomy club outreach. They bring the public, they educate the public. They also go to schools, and usually K-12 schools and even colleges have relationships. For instance, Union College and Amateur Astronomers Incorporated occupy the same space, and they, as part of the, I guess, the frills of being able to use the observatory, the astronomy club helps with the students on their telescope nights. So it's a give and take type of thing. Sample size, 25 posts. And the research question 3, I used peer-reviewed articles and other online sources because it was more relevant to that. So going back to the TAM, it does play a role. Our in astronomy club members or astronomers interested in new types of technology. Are new people to astronomy interested in something that's beneficial, but it has an easy learning curve. So it's a benefit versus usefulness and ease of use type of thing. And just this beginning of August, I went to the Northeast Astronomy Forum. It's a yearly astronomy conference. So basically, astronomers from all over the world descend on this place in Rockland County Community College. There's talks, there's collaborations, and things of that nature. And this is the vendors area. And again, these are those smart telescopes I was showing about earlier, geared towards the novice. So to walk everyone through this, this is, again, to research question 1, is a relationship to EAA used by amateur astronomers as light pollution increases. So as light pollution increased over time, the question would be, did amateur astronomers turn to electronic-assisted astronomy? So the specific words for question 1, things that we're looking for, EAA, video astronomy, light pollution, easy, or anything that's a synonym to those words, right? So also we have the notes section and themes to try to derive any kind of added meaning. And the data is also triangulated with other sources to confer reliability. The posts are also read 3 times to make sure that you've gleaned everything from them. So for research question 1 to 2A, it's a very similar process in all of this. For question 1, yes answer would constitute the person's attraction to EA because of light pollution. No would be because of other reasons. And again, we would look at the notes. A somewhat we'd have a nuanced, complex answer. And then we'd have to look at the notes and the themes to try to figure out what this poster meant and where to go with that information. So the data is all tallied and interpreted. Question 2 is also feeds off of question 1, or not-for-profit organizations, these is, astronomy clubs, using EAA as part of their educational outreach programs. Same type of sample size, and just enough for an exploratory study, right? 25 forum posts, you read them 3 times. This time we looked for EAA, electronic astronomy, outreach, public, easy. EAA could also mean video astronomy. That's another synonym. Sometimes EEVA, electronic assisted video astronomy. That's how they term it across the pond in Europe. They actually call it that rather than EAA. Again, consider the themes and notes for added meaning. Again, triangulate the data. This picture here is actually at Jenny Jump State Park. This is a small outreach, and you can see the screen is smaller. We had a small amount of people, this is again that same observatory that's open from April to October. And in the next picture here, you see the exact opposite at Montclair State University, the light polluted equivalent of that same club's what you call it, outreach events, usually during school time. So are not-for-profit astronomy organizations using EA as part of their outreach programs? Yes means they're doing it. No would mean it's not being utilized. A somewhat answer, again, nuance. Again, we address overall theme, and we look at the notes, and we tally the data. So the 2A, the sub question, did these same people decide to use a virtual version of EAA in addition to in-person? And so again, we're looking for virtual, broadcast, and easy, or synonyms to those terms. Again, considering themes and triangulating data. Off to this picture to the right here is an example of a amateur posting network. It's called Night Skies Network. So it allows amateurs, you create a username and you can, and password, you join, it's free to join, anyone can join. You can be an observer, you can be someone that wants to put your telescope out or showcase your observatory. And again, constructivist learning style, they are actually people who are interested in EAA often try to get their make their techniques a little better as opposed to just using it on their own. You have an audience, and basically they will converse with each other in a constructivist manner. Also, you can, as an educator, sign on if you have a relationship with one of these people who have an observatory, or even just use a telescope in their backyard, and you can have a virtual lesson online for free. So the picture here is of an annular eclipse. This was in West Texas in October of 2023 using a hydrogen alpha telescope. That's why the sun has all this interesting granulation, and you can see just the prominences at the edge there, which is kind of neat. So other ways that astronomy clubs, they also use Zoom like we're using right now, the North Jersey group. One that I'm a member of and worked with. We did a lot of Zoom, especially during COVID. We worked with the Buzz Aldrin Middle School and quite a few local grammar schools during that time to be able to show astronomical objects. We utilized a stellarium, which is a planetarium software, so to orient yourself in the sky. And this wound up working very well. So to go back to the data analysis process, a little hiatus, the yes answer, yes, they're using EA for virtual. No means they're not doing it. Somewhat, again, as a complex answer. Look for overall themes, specific words and phrases, and notes, and we tally the data. So this is the one that's the third question. How did astronomy educators change your mode of instruction because of the COVID-19 pandemic. This one proved to be the most difficult, at least for me, in the sample size, particularly because of the subject matter. We only had 7 articles. Some were peer-reviewed, some were, astronomy-based, like astronomy, notable astronomy magazines and things of that nature. And so, again, specific words and phrases, online, observing, activities, seminar, all these synonyms or anything that would be in the ballpark, we would try to glean information from here. And again, we consider any kind of notes for added meaning. And so the options were, did they just go asynchronous online only? Did they do virtual hybrid? Were they in person only? And we try to, devise the overall theme, and again, specific words and phrases. And the notes section is highly useful here when the data is interpreted. So now we reviewed, again, I gotta say, since I'm the sole researcher versus multiple coders, some limits the accuracy of the data set. You triangulated data, at least 2 sources, included peer-reviewed and other articles. Again, exploratory study, and the sample size is limited, especially the third one. One of the potential issues could be also researcher bias. I'm the sole researcher, and my involvement in the subject matter. So, looking at some of this this data, out of 25 subjects, was their relationship to EAA versus light pollution. 17 subjects answered overall yes, 5 were somewhat, and 3 answered no. So generally, making a generalization here, these amateur astronomers were open to the utilization of EAA because of light pollution. And so inductive reasoning, going into the meaning, inductive reasoning here, we looked at some of the notes and we looked at some of these categorizations. Who fell into the somewhat category? People that fell into the somewhat category, either they were very much in love still with visual astronomy, which I can understand myself. The other part is something that may be overlooked by unless you have you're used to special needs students with IEPs, visual impairment. They were able to see objects on a screen better than they can through the eyepiece because they had trouble viewing through an eyepiece for whatever reason, astigmatism, cataracts, or whatnot. So EAA this is something new we learned, that EAA was a good substitute here. And the no people, their answer generally meant that they preferred EAA to visual no matter what sky they were in. They like to look at deep sky objects, galaxies, and nebulae. They took their eyepieces, they hung them on the shelf, never to use them again, essentially. So in research question 2, are not-for-profit astronomy organizations using them for educational outreach? Out of 25, 23 answered yes, 2 answered somewhat, and none of them answered no. So not-for-profit groups are generally inclined to be open to the use of EAA. In going back to inductive reasoning, individuals that use EAA personally, some of these early adopters, they also using it in their clubs and outreach. So it seems like these particular people are the ones that are bringing it to their astronomy clubs and maybe then making it and introducing it to people in the club and even training them up. I can say that myself, that as the observatory chair was one of the things I do. Training the people to be a visual observer and then getting them trained on EAA scopes, should they choose to do so. So that's how this is spreading. So 2A, did they use virtual or during outreach to utilizing EAA? 20 subjects answered yes, 3 somewhat, and 1 no. So virtual broadcasting also seems to be one of the draws to EAA. Now, what if that was the initial draw, or it's a side effect, or a bonus? It's definitely, there is some correlation here to that. The ones that answered no, pretty much they're happy doing it in person. They have no interest in going online or and doing it in a virtual format. So research question 3, how did astronomy educators change their mode of instruction because of the COVID-19 pandemic? And again, the sample size is a little small, and that's a limitation here. 6 chose to utilize a fully online instruction. They went asynchronous, and 1 went in person only. Again, small sample size, but it is interesting to see there was no one in the hybrid category, at least at this point. Now, perhaps later, if I decided to open this up to other types of STEM environments, then the sample size probably could have gotten bigger. And perhaps, when we do the actual study in the future, that's what we do. So that's a concern with this particular run on things. So how does this add to the body of research? So EAA, can work as this particular study of EAA can work as a foundation starting point to do actual studies or in-depth studies. This has just been a local phenomenon, local astronomy clubs. They're in contact with educators, do not seem to, they know of its existence because of the astronomy clubs that interact with them. So maybe the idea is to bring this forward, to research this a little bit more. So again, it's a new and emerging technology. So who knows where it'll be in just a short amount of time. In particular with AI, that's another with the data processing. Implications. So there's an emergence of this new trend where you see astronomy clubs are utilizing this now, particularly in light polluted environments for education and outreach. The adoption of this technology in its many forms by institutions, educators. You can use them in astronomy labs and enhance the student experience, basically, and also increase accessibility to the content. So over on the left here, look at this picture. This is an outreach event at Montclair State University. You have the instructor acting as the guide on the side, and you have a mix of the public, and you actually have Montclair State physics students who are there to do their astronomy lab. And so you'll ask them, and you can coordinate with the instructor which objects you want them to want to look at. And you have questions set for them. They get to look at the objects on the screen or the object on the screen and talk about the processes that are going on in front of their eyes. And they get to talk amongst themselves and draw conclusions. And if, the instructor sees that they're going the wrong direction, you try to guide them. So this is a perfect example of a constructivist type of environment. The other piece here that this is a good for accessibility. We talked about eyesight. People that have trouble seeing can see these objects. And other thing is if, behind me, if you look, you see the wheelchair lift to the telescope. That's great. That can bring a wheelchair up to the telescope, but it's very tough for the person in the wheelchair to look through the eyepiece. Someone sitting in a wheelchair can view in comfort and actually participate with the group at hand in the exercise without any disturbance, without any kind of modification, a lapse in time, or anything along those nature. And then also just to go back to the difference in detail. The objects on the left, all of these objects on the screen are representations of the Orion Nebula, right? These are amateur sketches on the left here. The one all the way on the left is at a dark sky site, what this person saw through an eyepiece, maybe with a light pollution filter, and you can actually see detail. The one in the middle is a moderately light polluted what you call it, view. One you might see at Jenny Jump State Park, the darkest part of New Jersey. It's still New Jersey, for instance, you know. But the one in the middle here, this is what you would see in Jersey City, Staten Island, Montclair, with just an eyepiece. So you're missing all of this other part of the object is gone. It's disappeared. And EAA, the EAA image on the right, you can see what's going on. The shape of the nebula, for instance. Why is it that shape? So the lesson learned that students would have to glean here, there is these stars in the center here, also called the trapezium. They create their own solar wind, just like our sun makes solar wind, and it pushes out, once the star ignites, it pushes out all that material, and you can see all of this material, gas, dust, all these planet-forming, what you call, this is stellar nursery, but it's being pushed out. So any stars in this area over here are trying to gather through gravity, trying to gather their mass as quickly as they can before it gets dispersed too much, and they're out of luck. Again, same type of thing for the Andromeda Galaxy. This is all you would see, this the center core. But there's satellite galaxies, dust lanes, things going on in the EAA image that you can see brought to your eyes right here. So the TAM even applies at the astronomy club level. I was talking to Dr. Kozar last week. I was practicing the TAM and not even realizing it earlier on. So when we chose the telescope we were going to use for outreach, we chose a fast telescope, right? It was a meeting of the minds between the astrophotographers and the people that were new to this, right? And we wanted to make it as accessible to the novice astronomer within the club and learn how to use the telescope. At the same time, make it usable for outreach. So the astrophotographers setup would have taken too long to set up, and the small smart telescope maybe wouldn't give us the detail we wanted. So we wound up building our own type of setup, a fast telescope. The mount is something that the astronomy members are used to using in their outreach events. The software is the easiest software. It's the GWOASI Live. It's the easiest software to use. You start it up, you press go, and for the most part, without a lot of tweaking, you can get a really good image. And this is the Whirlpool Galaxy, which would otherwise be invisible in this sky. So as long as they know how to use the telescope, the club's basic telescopes, they know how to use EAA essentially without much of a learning curve whatsoever. Going back again to those smart telescopes, they are geared toward the novice, right? Their aperture is tiny. It's 30 millimeters, 50 millimeters. The biggest one is the Origin, that's 6 inches, about 150 millimeters. However, they will still show the brightest deep sky objects in a heavily light polluted environment. You can pack them up. You can use an app. They have an app to go with them. It's easy learning curve, and when you're done, you can put them on the shelf and bring them back out. So for someone in a K-12 environment with a limited budget, this is a great idea. You can, take it and use it, and basically an instructor that wants to show their students the universe without a huge learning curve, this is a good example. And I would probably say that the ZWO price point is the best one overall. The Vianis is a good system as well, but it does get more pricey in the intermediate zone. Again, it's kind of, I guess, how much usefulness for the amount of dollars spent. If you wanted to take the TAM and use it as a dollars versus ease of use. The other possibility is a remote observatory. And the really nice thing about these, and we kind of kid about them, we call them telescope farms. So essentially, it's a flock of telescopes, right? Essentially in their own roll-off roof observatory, and they're remote sites. For instance, if you have a school here in New Jersey, you can log on, get for a small fee, $40 a month, and it goes up depending how much access you want to the telescope. And you can log on to these telescopes, which are in Australia, for instance. It's 1, 2 in the morning if it's 1, 2 o'clock in the afternoon here in New Jersey. And so it's nighttime. So your students, who are very young, for instance, and can't stay out late, this is a great opportunity for them to look at the night sky and maybe do a lab exercise without having to stay up late. Again, for suggestions for future study, more in-depth content analysis, right? That's what a larger data set, bigger sample size on everything. Using more than one coder, perhaps a couple of trained coders, right? So it lessen the chance of errors and bias, and there's some intercoder reliability. An extension of that later on, be a doctoral level study, includes IRB, and you're using actual live students. Perhaps you would do, behind you here, you would do labs in a EAA mode, and you would do the same lab in a visual mode, and you'll see what student outcomes are like. And this might take a couple of years to do that, but that's one of the possibilities here that, where can this go later on? So what is the feasibility of this in the education environment? Right now, we have a lot of amateurs that are working with educators. And some of them are retired educators. That's, a lot of astronomy clubs are filled with people who want to do something or be a benefit to society in their retirement or even while they're working, like me. So a conclusion, again, we were just talking about this. EA is already being used by these individuals and the amateur astronomer community for multiple reasons, and the main one is light pollution. There's evidence that's already being used for outreach, and there also a virtual setting is also being utilized. The same people, it's not exactly the same people, it's not a one correlation, but I noticed the same usernames in the message boards coming up, that the ones that did outreach for their clubs, they seem to be also interested in doing virtual. So there is some correlation. They want to become more involved. So the hope here is that astronomy educators will become aware, and then maybe have relationships with their astronomy clubs, and then maybe join the astronomy club, because a lot of astronomy clubs need homes, and it's a symbiotic relationship. So those that, for instance, Montclair State University in the North Jersey Astronomical Group, they let us use the room, one of their meeting halls for our meetings once a month. We provide them with astronomy labs, and we work in tandem with the professors there. And it's also open to the public. And so again, more in-depth studies are definitely needed. And so I have about 7 minutes. I know I'm getting close to time here, but I put a compilation together of EAA in action. And so these are what these are, and this is a library that I'm actually continuing and improving. I compiled these for the reason of, what do you do with a lab? For instance, this spring has been very cloudy. I've had about 3 astronomy nights that were open due to clouds. But you're not dead in the water. You can, because I record these, I have the ability with OBS Studio, you're recording these objects, a particular phase of the moon. You can then carry on the lesson even though it's cloudy outside or raining, right? So for instance, here, this lesson, first quarter moon is a favorite because things are in profile. And the second one here is a very famous object. You've probably seen this Hubble picture in false color. It's usually yellow and blue. The Hubble PAL. These are the pillars of creation, and essentially this is it's low in our sky. It's usually a summertime object, and mostly invisible here. And so you can see these, like the Orion Nebula, these gas clouds are forming new stars and solar systems as we speak. And then again, the students can interpret what they see and what's going on here. Why is it shaped this particular way, right? For instance, why are there dark regions? The dark regions are usually dust, which winds up forming rocky planets later on from gravity. The red color is hydrogen alpha gas. So that's most of our sun, our star burns hydrogen. That's the material that basically coalesces and forms new stars. So this is a stellar nursery right here. The next one is very interesting. So if anyone remembers the news, comet Shushashan Atlas last October. So this was the comet that visited us from the outer solar system for the first time. It is a strange profile right now because of the camera sensor being long and the horizontal, it's tilted to the right. If you look to the left, that's actually the horizon, and up to the right is top of the sky. So I did it in this particular way so you can see that as much as the tail as possible. But one of the lessons here you would show students, and yes, there are planes flying past it and satellites. You can see that this was a live image. Look at these two stars. We'll get my pointer here. These two stars here, right? Versus the comet. You can see the comet is moving up and to the right over here relative to these two stars. And I'll reverse this video again in a second and go back. It's going to happen right about now. Okay. There it is. So it's going back down the horizon over here. The sun just set to our left, right? So the comet, the tail is pointed away from the sun as it exits and goes out the solar system. And you can see that this is, again, a piece of the outer solar system, the debris left from the beginnings of our solar system's formation heading back on out. And this final one is very special to me. This is the total solar eclipse we had last year, April 8th, 2024. So I had about 2 hours of data here, but yeah, and that's me just announcing that first contact here. So I actually went up with Dr. Mary Lou West with her family in Burlington, Vermont. It's in the path of totality. So a lot of people traveled to see this. So I looked at this visually myself, right? While I had a telescope, a small refractor, and a white light solar filter. So you can see these are sunspots, one over here, and the moon's disk is coming in, heading in, and we'll cover the sun. And at that point, I'll take the solar filter off. It's safe to view. The whole idea is, it's not safe to view the sun with your eyes. It's also would damage a camera sensor and destroy the camera the same way. So here we're about to enter totality, and I'll do a couple of things here. So you'll see a couple profiles. The camera, so I go outside, I take the lens off. You can see at the 10 o'clock position, the 7 o'clock position, I have the gain low at this point and the exposure is low, but you can see these prominences. These are solar flares. So only see that during this particular time, unless you have a special hydrogen alpha filter. And so give it a couple more seconds. I'll go back and adjust this because this was my first eclipse, total eclipse. So I had the opportunity to broadcast this. I decided not to. I talked to many eclipse chasers that do travel the world to do this. And they said, if you're doing this the first time, you want to experience, and this is the reason right here you're about to see right now. That is the corona. That is the sun's outer atmosphere that we're looking at. And this is a teachable moment. This is a video, a matter of fact, it's in Sperry Observatory. I kept its library there. So when I'm not there, other members can use it, particularly if the talk is about eclipses or anything. That is there for them to use. Solar eclipses don't happen very often. The next one that will come, a total solar eclipse rather, the next one will be 2044, will be back on the mainland United States. So we have a very long time. So this was, again, unless you book a trip somewhere, like for instance, Spain in 2026, you're not going to get to see this. So these recordings are useful, and you can use them in anything. You can use them in a classroom. You can use them online. And again, you can see at the bottom now, the sun is about to come out, the moon is ready to move off, and it's going to go back. Yep. All right. So now we're going to put the solar filter back on, and the moon pulls away. And again, I'm speeding this up. This is 2 hours worth of data here. But the moon moves off the disk here. And that's about, yep. Okay, so from here, all right, so here are my references for the slide deck only. These are not for the paper. Some of them are from the paper, but the ones on chapters 1 to 3 are part of chapters 1 to 3. And I'll go through more of these. Okay, and so I can open up to questions if you like, or do you also, if we have time, I can show with the video camera the observatory and the telescope if you guys want to see that as well. So feel free. Yes, any questions?
I vote for seeing the rest of the observatory if you don't mind.
Sure, no
I also
problem.
don't want to jump in if anybody else had questions that they wanted to ask first.
Sure. Okay, no, so I'll
Let's go, Mark. Let's see it.
all right, let's take us on a virtual tour here.
Yes, I'd love to see it.
All right. So we're very lucky. I was very surprised when I was asked when I applied for a job here at College of Staten Island. They knew about my astronomy experience. They actually immediately said, we need someone. The person that ran the observatory retired because of COVID. They decided they were here long enough, and so they had no one that can actually run the telescope. So behind me here is Meade LX200, right? And I have it set up, and I'll notice there's another telescope on top of it. So this telescope here, you can see also has a camera. You can use it for video, you can use it for visual. That can be used for solar observing, and it can also be used for wide field. For instance, this big telescope here, it's got a long focal length. It's got a long focal ratio. So it's really good at seeing very faint objects that are tiny. If it's a large object, it won't, it'll spill off the screen, or it won't fit in the eyepiece. So this smaller telescope will take the place of that. And even though the aperture is smaller, most of your larger objects are bright enough that you don't need as much. Also, the smaller telescope is a faster focal ratio. It's f5. So even though it's a smaller aperture, it makes up for it a little bit because of the faster system. I would love to put a RASA in here, and hopefully, if funding permits, and I'm sure they're going to ask for, they have donors that are that may actually help us with that. But a RASA in this situation, because of the light pollution, would work really well, and it would be, again, piggybacked on top of the telescope. So you notice there's a bunch of screens. The computer in the middle here actually would run the telescope. The computer up here, and this is very important, will also run the telescope, but it's running Stellarium software. And I ran it a couple of hours into the future, so you can kind of see where in the sky you might be pointed. I use this with students often because, well, we're in a dome. We're not outside looking at the entire sky, so it's a little bit concealed. It's also good for online use. So during COVID, this was a great tool, and it's free. It's called Stellarium. You can download it on your computer for nothing. And you can actually use it to point telescopes too. It's got that capability. But any kind of information about the object, how far away it is, all of that stuff is at a touch of a fingertip right there. This over here is another example. This is usually the main where the imaging part would come into play. I sometimes have a bigger screen here as well, or I have a screen outside if we have a large group, or on the lower level, we'll have that as well. The dome does rotate. See if I can go for a second. So it can move either way, wherever you're pointed. At some point, when we upgrade the telescope, I'm going to get encoders so the dome will turn automatically with the telescope. The dome slit actually opens as well, which is kind of cool. And so again, it's daylight out, but that is how this works. The lower part is also useful. It will, if there's something low on the horizon here, that part can be lowered as well. The bad part about that is the soccer field lights will try to make their way in here. So I try to keep that up as much as possible, especially if I'm looking towards that. But this is the dome, and I can actually bring you guys outside. See what that looks like. And yes, there's enough Wi-Fi signal, it won't drop here.
Mhm.
So we have the soccer field, everyone's here to the right, and then there is the dome and the observatory. So it's its own building, it's considered its own lab.
That's awesome.
There are satellite dishes also. Once upon a time, we did radio astronomy. That's astronomy in radio frequencies. Further down over there's another one. We eventually want to hook those back up again. Get this in. So we do also use eyepieces as well. Mostly again, for planets. They would go in place of the camera. If you, right here, you can see there's a focal reducer. So this is an f10 telescope. It's a slow telescope. So what that means is it takes a lot longer for the camera to grab light. The focal reducer brings it down to about f6, which will, again, if you have an audience and you want to get an image up quicker, you definitely need focal reduction for this telescope. Some telescopes are faster natively. And again, for educational purposes, that's what you'd rather have. So yeah, if you guys have any questions, please let me know.
I love this. This was awesome. Thank you so much for sharing so much. I really enjoyed it.
My
And
pleasure. My pleasure.
it's really cool. It's not something you get to see every day, especially. So it's great.
It isn't. I'm very lucky in that sense. I mean, I do run two other telescopes, two other observatories. One of the ones is the one you saw in Jenny Jump. The other one is, matter of fact, I'm there tomorrow night at Sperry Observatory in Union College. I'm a qualified observer there. I run the 24-inch. There's a lot of other members run that telescope as well. That is an old telescope from the 1970s that was modified and brought up to speed. However, now we have a little refractor on this one. There is a RASA on top of that 24-inch, which we use for EAA. Again, we took advantage of the fast scope, and we use it not only in the observatory. There's a large plasma screen in the classroom, and again, you could put a screen outside. And also the meetings. The meetings are also hybrid, so there's usually a class, and so even the meetings and after the meetings, the observing can be broadcasted. It's all hooked up and ready to go. That's kind of nice because you have a classroom in between. If anyone has been to Union College, and I think Dr. Kozar might have been. Oh, what days am I at Union College? So I'm there every 5th Friday. So I'm on Team B. So this week I'm there, and then I would probably be there again the second week of June. It's 5 teams. Probably the second week of June I'll be back there again. I know tomorrow I'm there, but I have a feeling I think it's going to rain for no, Friday. Sorry, it's today's Wednesday. So Friday I'm there. But every Friday they're open, rain or shine. They have a presentation, and you can see the telescope there. And also, again, that same EAA library is there. I'm trying to update it because my technique has gotten better since I started in 2020, really compiling this. And the software has gotten better as well. So so the image is getting better. There's definitely an AI component to some of this software, and as time goes on, it'll only get better and easier for people to use. And so that's basically my presentation here. And this is one of the things I happen to love. I'm glad I could share that with you.
This is great. Thank you so much, Mark. That was wonderful.
My pleasure.